Hello everyone, in this video we are going to see about how to convert the post order expression into a pre-order expression. In the last video we have seen how to convert an pre-order expression into an post order expression. Now this is the reverse case. Let us see the example. That this is the same example we have done in the last video for our conversion from pre-order to post order. Okay, so now I have given the written the question here. The question is written over here, and then I have the step 1. As usual, you have to arrange the numbers in the ascending order. So I have arranged from smaller to bigger number, so the order is here. So this till this step it is same as the previous method, because the concept is when you are arranging the elements in the in order, we are getting the, that is when you are arranging the elements in the ascending order, we are getting the in order traversal. So that's a very simple logic. Suppose if the question is given as a find out the in order traversal of a tree, and if some options are given, we can just find out if something is in order, so that is the in order traversal of the expression. Okay, so now coming to the second step of this algorithm. So now we have to now draw the BST. BST is the binary search tree. So first, as usual, you have to start from the root. We have to find the root. So what is the root here? So this is the root. So now the root has been fixed. Now I have to start from the root. So the root is fixed and the root is now 30. I have drawn this root. Now let us see how to go down the branches. So here, next we have to find out so now the position of this 30 in the in order expression. Now this is the position of 30 in the in order expression. Okay, so now this forms the right tree and this forms the left tree. Okay, so now we can choose either to the left tree or right tree. Let us start with the right tree for convenience as we wish. So we'll just complete this right tree and then we'll go to the left tree afterwards. Both are same, we can do as we wish. So now here, now these are the three elements available, 35, 39 and 42. Now we have to find out the next root of the tree. Okay, so as we are going to the right direction, so we are going to only fill this direction. Okay, so now 35, among 35, 39 and 42, what is the root you have to fix? So as we are done in the previous video, the same thing, to find the root, go to the given. Okay, so for the pre-order we have started from, so actually when you had the pre-order expression, we have started from this direction. Okay, now this is the post-order expression, we have to go in the reverse direction. That's it. So now I have started from the reverse direction. First initially I fixed 30 as the root, and now I have to proceed that way. So now coming to the next one, this is the next root. So I have to, this is the root of the, that is the right root, because I am drawing the right subtree. So I have to draw this tree as right tree, which is actually 39. So now the root has been found out. So once the root is found out, what is the next step? Find the location of this root in the in order expression. So this is the position of this 39 in the in order expression, and now find out the left and the right. So now here, since only there are three elements, we can easily find out to the left that is 35 and to the right that is 42. So we can just write the elements as usual. So this is the right, this is the left child, the value is 35, and this is the right child and the value is 42. So now this subtree is over. So once it is over, just you cross the things what you have already done. So still 42 is over and 35 is over, and this is the main root. We started, that's the main root. Okay, so now these are all the elements now that belongs to the left subtree. So now how to draw the left subtree? Again you have to start the procedure, and again this, since the post is given, we have to go in the reverse direction. Okay, so now till this the things are over. Now we are this is the left down values for the left subtree. So again we have to locate the root. So what is the root here? Now the root is, okay, now we have to start with the root. Now this is 20 is the first element, so we'll start with this direction. So now the root is 20. So just draw a branch and then just give the value as 20. I given the root of the subtree, and now we have what is the location of this 20 in the expression. We have arranged the in order. So to the 20, here 10 and 15 are there to the left side. The right side 23 and 25 are there. So now how to complete the left and the right subtree? Again we have to go back to the given order expression. So now we can see that to the 20, after this 20 we have 25. So 25 is the root and I have to take this 25 as the root. So now here, since we are going in the reverse direction, we are in the first the right subtree. So we have to draw the branch which is the right subtree, and the answer is 25 for this child. Okay, and then once you fix the root, we have to go to the in order expression to find out the location of this. So now this is the location, this is the 25, this is the node, and now I have to find out here to the left what is there. That is 20. To the left of 25, 23 is there, but to the right there is nothing is there because this tree is over. Okay, this tree is already over, so only this is the element available. So 25 is the end, and now to the left there is only 23. So I have to make this 23 as an subtree of 25. That is the left subtree. So I have to draw the tree as this is equal to 23. So now here 20 is over, 25 is over, 23 is over. Now I have to find out the remaining subtree, and this is the root of the subtree. Now I have to now go with the 10 and 15. With the 10 and 15, which is the root and which is the subtree, I have to find out. So now again go to the given expression which is the first order, and now 10 comes in the first and the reverse order. So 10 is the root. So which side? This is to the left side of 20. So we have to draw the left subtree. So left subtree of 20 is here, it is actually 10. And then find the location of 10 in the in order. So this is the value 10, and we have to find the location. Here in 10 we can see there is no left, but there is a right value. That means here the left branch is null, but the right branch is 15. So we have to draw the tree as right branch is equal to 15 and the left branch is null. So now this is how the tree has been drawn. Now what is the procedure? Now we have to make this is the in order tree. Okay, so now we have draw the in order tree. Now it is the time to find out the in order traversal, so that we will get the, we have to go through this in order tree to find out the pre-order traversal. We are going to convert from post order to pre-order. First step, we arrange the elements in ascending order, and then from the ascending order we have drawn the binary search tree. So once you draw the binary search tree, we can go to the traversal as usual. Then we can find out the answer, which is the post order expression. So how post order expression, and here what is the post order traversal is, we have to go by first left has to be traversed, and then right has to be traversed, and then the node which is the root has to be traversed. This is the order of this post order. So we start with the root and down to the node. There is again left is there, so keep on going to the left till there is no more left is available. Now for this there is no left subtree, it is an termination. Okay, so to the 10 there is no left subtree, so with that means we are going to stop the traversal. Now we have to find out the right. So what is right here? The given is the right is the 15 is the element, so left is null. Actually what we have to traverse is left to right node. So we have down the node, we have down the branch we have come, so there is no left tree, left child, leave it, and then go to the right one, and then go to the node one. So 15 is the right child, and then for this tree this node is this is the node, so write the value as 10. So we have left right node, left is null, then right is 15, and then node is 10. Then we have to go to the next level, and then this is actually left, then you have to go to the right. Okay, so this is the right is 25, but 25 has still some tree is there, till some subtree is there. So we have to go till the terminal, till the terminal branch. Okay, so now 23 is the available pattern. So what you have to do, we have to write this 23 because now we have come to this subtree. So 23 is left, there is nothing in the right, but in the nodes of values there. So as the procedure goes, right node, so left is 23, right is nothing, leave it, and then the root is 25. So now this branch is over. Now we have to go to the traverse to the up. When you traverse up, this is the left child. Okay, so we have to come to the, we have to just traverse the child, which is the left child, and the answer is 20. Now what you have to do, you have to go to the right child. Okay, so to the right child, what is the value? 39, but we cannot write 39 now itself because there are some branches. Get down to the left. So till we'll go to the left, 35 is the left, last left. So we have to write value as 35. And then after that, right child is there, which is 42. Then afterwards, left and right are over, root is there, which is 39. And then finally, this is the root, which is 30. So that's all the post order traversal of the given expression. So now this is the way we can find out the traversal of the binary search tree. Now the answer is 15, 10, 23, 25, 20, 35, 32, 39 and 30. So this is the post order traversal of the given expression. Now if you check this answer with the previous video, we can see how we came from this post order to this pre-order. Just to make a confirmation, just I have taken the same example so that the previous video, the pre-order is the post order is converted into pre-order. In this video, I converted the same post order into pre-order. Okay, so the same question is taken for confirmation. So hope this will be easier for you to follow, and thanks for watching.